Okay, so this video is about overloading the assignment operator in C++. We're talking about overloading the assignment operator for a particular class, and the class that we're going to be doing this for is the pair class. If you look at this class, you see there is one member variable. The variable is a pointer to an int. Okay, so let's see how this is used. There are three constructors, including the copy constructor for this class. So let's just look at these three constructors for the moment and see what they do. Okay, so these three constructors all allocate a dynamic array of size 2 and store values in that array. Okay, so apparently what a pair object is an object that stores two values, and rather than using two individual variables for this, it uses a dynamic array. Okay, and depending on which constructor we call, two different values are stored in the object. And actually, let's just double check. So if we use the default, the no argument constructor, we store a 0 and a 1. This constructor stores duplicates. This constructor stores the two values. Okay, so that's essentially how the class operates. We also have set methods, set functions for each of the two variables, and get functions for access of each of the two variables. Okay, the class also comes with, or it actually travels along with, a output operator, an output operator overload for a pair object. So we are able to use this stream operator with a pair object. So starting right from the beginning, let's see what's going on. Here we're creating two pair objects. One's called 1, second object's called 2. The first object will store a 6 and a 7 in the object 1. The second object 2 will contain a 0 and a 1, as we saw from that particular constructor. So we would expect, when we see the output of this statement, that it will display those two objects described. So let's look and see what happens here. Okay, so we see that object 1 contains a 6 and a 7, object 2 contains a 0 and 1. So everything works as we would expect it to work. Now I want to add a little something to this. I want to assign one pair object to another. Now typically in C++, when you have two objects of the same type, and you assign one to the other, what basically happens is that C++ will take the values in each of the member variables of this object and store it in the member variables of this object, so that the two objects will be identical after the assignment. That's what would typically happen. So let's see if that's what happens with our pair objects. Okay, so now we look and we see the output from our initial output statement. We see after the assignment, both object 1 and object 2 contain a 6 and a 7, which is what should have happened. Okay, so we can assign one pair object to another. Now I'd like to, do something else. Let's call setVal1 with an 88 on object 1. Now what this should do is set the first value stored in object 1 to 88. So object 1 should now, I would expect, contain an 88 and a 7. Right? So let's do the same thing again. I'm actually going to I'll just so I'll have a blank line before this output. Okay, now what do we see? Okay, our initial output after the assignment, they're identical now. Well, object 1 does contain an 88 and a 7, but object 2 also contains an 88 and a 7. So that's unexpected. I wouldn't expect if I change object 1 for object 2 to be changed. So let's view why that happens. In C++, when one object is assigned to another, C++ uses a default assignment operator. And the default assignment operator basically works like this. Okay, here I happen to have an overload for an assignment operator, but the default assignment operator works like this. It copies the variables in the right-hand part of the assignment, right-hand object, into the member variables of the left-hand object. Okay, that's how assignment is done. Copy the right into the left. That's assignment. That's how objects are copied. Except it's usually done member variable by member variable. So that's all this particular method does. It takes the values, member variable B, and stores it in A if A and B were the two objects involved. Okay, and so that's what C++ does if I don't overload this operator. Okay, and you can see how that behaved, right? And you can probably have a good idea of what the problem is here. Object values, or any of the values in general, store what? This stores a pointer. It stores a pointer to a dynamic array. So I'm taking the address of a dynamic array and storing it in another object. So now this second object is also referring to that same dynamic array. Okay, so this is not what I want to do in the case of my pair class, because my pair class contains a variable that's a pointer. So if you have a class, whenever you have a class where one of the member variables is a pointer, the default C++ assignment operator will not work properly for you, because it's just going to copy one pointer to another, and you're going to have the two objects that were involved in the assignment will be related. Okay, they'll be sharing memory. So this is not what we want to do. I have to overload the assignment operator so that for the pair class, specifically the way I want it to work, so that assignment will work properly for a pair. Again, the overload that I had here, if I had not had this here, that's the way the C++ default one works. I just typed it in advance so I could show it to you. Okay, so now what I really want to happen, this is a little different than the copy constructor. It's similar idea, assuming you've already watched the copy constructor video. What the situation here is that the left-hand operand has a member variable. Okay, has a member variable, and it actually its member variable is pointing to an array. Okay, so this particular object has a dynamic array that its values variable is associated with, and of course this one does as well. So rather than causing them to share an array, all I really want to do is take the values, the data in the 0th element of values on the right-hand operand and stored in values in the left-hand operand. In other words, I'm taking values sub 0 out of this object and copying it into values sub 0 in this object. And the same thing for values at 1. Okay, so again, rather than copying the member variable itself, I'm copying the data that is being pointed to by that member variable. Okay. So now let's come back here and look and see if things work any better now that I've overloaded the operator in a way that makes sense for our class. And yes, we see now that I changed that overload for the assignment. When I make a change to 1, I'm not affecting 2. The object 2 remains as it was. Okay? Okay, so that's pretty much the idea for overloading an assignment operator. You only have to overload an assignment operator when your class contains a member variable that's a pointer, and you have to do that so that you handle that pointer copy correctly. If any other member variable that needs to be copied over can be very simply copied over in here as well, but you have to make sure that you think through how to work with your pointer variables. And then there's one last thing. Typically, here's what we're talking about here. Typically, we know we can do something like that, right? Sure, you can do something like that. And the overload that we've provided this will work fine, okay? But we usually, when we overload a operator, we want to overload it the way the language operator works. So the standard equal assignment operator there in C++, you're allowed actually to do multiple assignments in one statement. It's not always the most readable thing. People don't necessarily do it a lot, but you can do it, and it should work for your operator. So the way this actually works is in C++, C is assigned to B, and then the value of B is assigned yet to A. So in other words, this assignment here returns something. There's a result of it. In addition, in this assignment in general, even if these were ints, when C is assigned to B, the result of this operation is the value that was assigned, namely the value that's in B, and then that is yet assigned to A. So it's like there's a return value from that operation. So I want to change my return type here to be pair, to be a reference to a pair. Okay, so in other words, when an assignment is made with one pair to another, if these were all pair objects, when an assignment of one pair is made to another, there's a value returned. Namely, it's a pair that can then be assigned to the next one in the chain. Okay, so to do this in my implementation, I have to change my return type so that these things are the same. I'm returning a reference to a pair, so a pair can be easily accessed. And what do I want to return? Well, again, when we saw, we just talked about it, A equals B equals C, right? C is assigned to B, then the value of B is what's used to be assigned to A. So it's B, the thing that was assigned to, that is the result. Okay, so I need to return something. Namely, I need to return the object that was just assigned to. So the object that was just assigned to is my calling object, right? So my calling object, if I want to refer to that from a method inside of a class, I say, well, this is a pointer to my calling object, so star this, dereferencing this, is my calling object. So when I say return star this, I'm saying return the object that this particular function was called with, namely return A, okay, or return B if this was the assignment we're talking about, and then I'm returning it as a reference. Okay, so that C++ can access its memory location. Okay, so now, having done this, we should see let's see, we should see that we can make multiple assignments and the compiler won't complain. And if we print out after making our assignments, we should see that the three objects are the same. And if we change any of the objects after making these assignments, the object should be clearly unique. Okay, so let's see. Everything should have a 6 and a 7 after this assignment. And then we should see 3 unique values down here. A 88 and a 7, a 77 and a 7, and a 6 and a 7 for that one. So let's see. Just quickly verifying that this works. Okay. Okay, so these two are on the same line. Sorry, I didn't put anything in there. So we have 6, 7, 6, 7, and 6, 7 right here after our assignment. That after I've changed the first value of 1 and 2, objects 1 and 2, here's object 1, here's object 2, and here's object 3. So I'm able to change my assignment statements due to my new return type. Okay, so I think that's pretty much everything you need to know about overloading assignment operators. The only other thing that might come up in our situation, our pair class tends to have 2 dynamic arrays that we know are always of size 2. If for some reason pair objects had dynamic arrays that were different sizes here, I would actually have to check that the sizes of the 2 arrays were identical before I did this assignment, and if not, reallocate the array in the target object. Okay.